Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 8th video in the Introductory Programming in Java full course. In the last video, we defined expressions and looked at examples of arithmetic expressions. Expressions can be made up of variables, literals, and method calls that evaluate to a value, combined with arithmetic operators. Today we're going to talk more about the arithmetic operators in Java and order of operations. Let's get right into it. For this video, we're going to use jshell, an interactive tool for learning the Java programming language and prototyping Java code, according to Oracle's Java Shell User's Guide. I'll include a link to that page in the description. If you've used Python before, jshell is like Python's immediate mode, in which you can type a programming statement and it is immediately evaluated. jshell will allow us to type Java expressions and see their values without surrounding them with a class, main method, and printline statements, and without having to then edit and execute a program. To run jshell, run the command prompt and then type jshell. If Java is correctly installed on your system, the prompt will change to jshell close angle bracket. As a quick example, recall that literals evaluate to exactly what we type. So let's type a literal at the prompt 3.14 and press enter. jshell responds with $1 arrow 3.14. We can define variables in jshell as well. For example, I can implement the expression from our last video that evaluates to the square root of a squared plus b squared, the hypotenuse formula. I'll type int a equals 3, enter, and jshell responds by telling me that a is 3. Now I'll type int b equals 4, enter, and jshell tells me b is 4. Now I can type the hypotenuse expression, math.square root open paren math.pow open paren a comma 2 close paren plus math.pow open paren b comma 2 close paren enter. And jshell responds with $4 is 5.0. Those two variables with the dollar signs in front of them, $1 and $4, are scratch variables. If we type an expression without assigning the result to a variable, jshell will assign the result to a scratch variable. We can actually evaluate those scratch variables. Notice if I type $4, jshell responds with $4 is 5. This is different from a program. Note that if you write a free-floating expression in a Java program, you can't access it in any way. It's not impacting your program execution at all. You need to do something with expressions you write in a program, such as assign them to a variable or print them or include them in a larger expression. Alright, so now that we've had an introduction to the jshell environment, let's take a look at the Java arithmetic operators, learn about division and modulus, and talk about order of operations. Here's a page from the Oracle Java tutorials that is a summary of Java operators. We'll focus on the math operators. Under arithmetic operators, you see the plus sign for addition and also string concatenation, appending two strings together, and then the minus sign for subtraction. So far, nothing crazy. The asterisk or star for multiplication, and the forward slash for division, as you've seen. And then there's the percent sign, which is used for mod, finding the remainder of an integer division. It has nothing to do with calculating a percent. Now, these work mostly the way you'd expect, except for division. The division operator has a little quirk that can lead to errors if you're not careful. You'll find this quirk, by the way, in many programming languages, including Python 2, but not in Python 3. So if you're coming from a Python background, or if this is your first programming language, you might find this surprising. All of these operators are overloaded, which means they can work for different data types. The plus operator can work on the different kinds of integers, the different kinds of floating point types, and also strings. As we said, it will concatenate them. We can illustrate this in jshell. If I type 5 plus 7, jshell evaluates this to 12. And do notice that both the 5 and the 7 were integers. So the 12 is also an integer. Now I'll type 5.0 plus 7.0. And jshell evaluates that to 12.0. That will be a double, the default floating point type in Java. Now, what about 5 plus 7.0? That is also 12.0. Why is that? Why does it work? Why isn't it an error since we're trying to add literals of two different types? And how did Java choose to make the result a double? There are rules for this, of course. I'll include a link to this page from oracle.com in the description, showing the different contexts and rules for type conversions. Java will perform some type conversions, converting a value of one type to a different type, in the context of an arithmetic operation so that it can compute the operation. The conversion we just saw, converting from an int to a double, is a widening conversion. Widening conversions will convert smaller integer types to larger integer types, and a float to a double, or it will convert the integer types to the floating point types. It will not convert the other direction, larger types to smaller, or floating point types to integers, because information will be lost. So widening conversions will happen implicitly. Java will just do them, because there is generally no loss of information. Moving on, in our operators, subtraction and multiplication will both work on the integer and floating point types. Think about the value that gets returned or the value that the operation evaluates to. If I add two integers, I'm going to get an integer result. If I add two doubles, I'll get a double result. And if I add two strings, I get a string result. It's the same for subtracting, multiplying, and dividing integers or doubles. Now, you probably wouldn't even think about the difference between subtracting and multiplying integers versus floating point numbers, because if you subtract or multiply two integers, you always get an integer result. You can't get a floating point result. But if you divide two integers, for example, if I divide 10 by 3, I might expect to get 3.3 repeating as the answer. Let's try that in jshell. I'll type 10 divided by 3 and enter. And jshell says 3. That is not what most people expect. But because both operands are integers, Java will calculate an integer result. The integer result is the floating point result with the decimal part truncated. Another way to think about it is, an integer division answers how many whole divisors will fit in the dividend. 3 whole 3s fit in 10. If we want a floating point division, then one of our operands has to be a floating point value. Let's try 10 divided by 3.0, enter. Now jshell says 3.3 repeating. Now, if you have an integer variable, you can force it to be cast or type converted to a floating point type. Remember our variable a? I'll type a, enter, and jshell responds that it's 3. Let's put 10 into a variable as well. I'll write int dividend equals 10, enter. Now I have two integer variables, dividend and a. If I want to perform a floating point division, I can force a conversion of 1 to a double for the purpose of the calculation only. It won't permanently modify the variable. To do that, I write double in parentheses before the variable I want to temporarily cast or convert. So whereas dividend divided by a, enter, evaluates to 3, double dividend divided by a, enter, evaluates to 3.3 repeating. So here it's important to recognize that the result of an operation is going to depend on the data type of the operands. And if you are computing a division, be careful to remember that when you divide integers, you will get an integer result. If you want a floating point result, you must make sure one of your operands is a floating point type, or is cast to a floating point type for the division. Now let's talk about mod. The mod operator is the percent sign. Again, that is not computing a percentage. The percent sign, the mod operator, is computing the remainder of an integer division. Let's think back to our example of 10 divided by 3. The integer division tells us how many whole 3s there are in 10. The mod tells us what's left over of the 10 after we've taken as many whole 3s out as we can. Let's write that. 10 mod 3 enter. And we get 1. There's 1 left in the 10 after we've taken as many whole 3's out as we can. Maybe you even remember a time when you were learning division, but before you learned about decimals, in which you would say 10 divided by 3 is 3, multiply 3 by 3 and you get 9, subtract the 9 from the 10 and you get 1. You can't divide 3 into 1, so 10 divided by 3 is 3, remainder 1. You can see this is written as if it were a division, like 10 divided by 3. So the same dividend and divisor, but we're asking for the remainder with mod. This is a useful operation in programming. For example, if we mod a number by 2 and the result is 0, that means that 2 divided evenly into the number, and it's even. If we mod by 2 and the result is 1, that means there was 1 left over and the number is odd. You can determine if it's a leap year with mod as well, if the year is divisible by 4 but not divisible by 100, or if it's divisible by 400, then it's a leap year. You can also use mod to constrain a number to a certain set of sequential values. If you play around with mod, you'll notice that if you mod by some number n, you will always get an answer between 0 and n minus 1. For example, 1 mod 4 is 1, 2 mod 4 is 2, 3 mod 4 is 3, 4 mod 4 is 0, 5 mod 4 is 1, 6 mod 4 is 2, 7 mod 4 is 3, 8 mod 4 is 0, and on to infinity. Now, there are also unary plus and minus, which you might think of more as part of a number than an operator, but in a programming language, it's an operator because you can negate any arithmetic expression, not just a literal number. Unary means that it's an operator that works on one argument. So whereas subtraction takes 2 operands, the minuend and the subtrahend, the unary minus operator simply negates the single expression it's to the left of. And the unary plus operator works the same, although it doesn't change the value of the expression to its right. If you have a negative expression, putting the unary plus in front of it will not make it positive. Now, this table shows the order of operations in Java, and you'll see there are operators that are unfamiliar in this table. Don't worry about that. As we learn operators, we'll return to this table so you know where they fall in the precedence. If you're unfamiliar with that term, precedence, you're definitely familiar with the concept. It's the order in which operations will be carried out if there are multiple operations in an expression. You may have learned a mnemonic, PEMDAS, in school, and that also applies in Java programming. Parentheses are at the top, meaning you can force a high precedence by putting parentheses around an expression. Now after that, near the top, we have the unary operators plus and minus. Directly below that, so next highest in the precedence, is the multiplicative operators, multiplication, division, and mod. These all have the same level of precedence, just as they do in math, so they are evaluated left to right in an expression. After the multiplicative operators come the additive operators plus and minus, and again, they have the same level of precedence, so they're evaluated left to right in an expression. Let's look at an example. We have our variables defined, a, b, and dividend. Let's use those. Suppose we have the expression dividend divided by a plus b times 2. Look at the operators in the expression, division, addition, and multiplication. Which operators have the highest precedence? Division and multiplication have the highest precedence, and the same precedence, so those will be evaluated first, left to right in the expression. Dividend divided by a, recall, is 3, because that's an integer division. And b times 2 is 8, because b is 4. So we're left with 3 plus 8, and now we have only one operator left, the addition, so we can add those results and get 11. And if we type that into jshell, that's what we get. If the operators had a different precedence, we'd get a different result. For example, if plus had the highest precedence, then 3 and 4 would be added before we moved on to division and multiplication. Or if there were no precedence and all operations were evaluated left to right, then the division would be computed, giving 3. Then we'd add 4, giving 7, and then multiply by 2, giving 14. This is why we must have a precedence, so we all get the same answer when we perform arithmetic calculations. Again, these are the same precedence rules as math. And remember that mod is also a multiplicative operator, so it will have the same precedence as multiplication and division. I've got an auto-graded exercise in the description of this video to help you practice with this. Click on the link and you'll go to an exercise that allows you to practice with some of these math operators. Because we didn't write a program in this video, you'll have to carefully follow the instructions in the exercise to get it to come out correctly. You should also practice evaluating common expressions by hand and confirm the results with jshell or a Java program to make sure you're comfortable with operator precedence, and practice with the mod operator. Make sure you can always identify the data type of the result of an operation given the operand types. Again, you can quickly check your answers in jshell. When you're feeling confident with order of operations and the division and mod operators, come back for more with the next video. As always, have fun and keep coding.